goal here is to find the local max value, but first we have to find where the local max occurs. In order to do that, we'll need the derivative. F prime of x here will be 3x squared minus 12. And we'll use that to find the critical points of this function by determining where is the derivative equal to 0. So where is 3x squared minus 12 equal to 0? And where is it true that 3x squared minus 12 does not exist? To solve 3x squared minus 12 equals 0, in this instance we can isolate the x. We can add 12 to both sides, and then we have 3x squared equals 12. If I divide both sides by 3, I get that x squared is equal to 4. So then I take the square root of both sides, and this is a little bit tricky. Remember, a number actually has two square roots. So I would have x equals positive 2 or x equals negative 2. These are my two critical points where f prime of x is equal to 0. For the other case, where is it true that f prime of x does not exist, this doesn't happen. F prime of x is a polynomial, and so it's defined everywhere. Now I take my two critical points of x equals 2 and x equals negative 2, and I'm going to use them to make this sign chart. So the dividing lines on my sign chart are at x equals 2 and x equals negative 2. I'm interested in f prime of x first, but then I'm also interested in what I can do with f of x. So on this interval from negative infinity to negative 2, I pick a test point, and my test point will be something ridiculous like x equals negative 100. So f prime of negative 100 is equal to 3 times negative 100 squared minus 12, which is the same thing as 3 times 100 squared minus 12. I don't need the exact calculation here. What's important is that f prime of negative 100, and so f prime of every value from negative infinity to negative 2, is positive. From that, I can interpret that and say that f of x is increasing on this interval. For the second region, I'm going to test x equals 0 because it's easy and I can do it. So at x equals 0, f prime of 0 is equal to 3 times 0 squared minus 12. And if I simplify that, I get f prime of 0 is equal to negative 12. So f prime of 0 is negative. So f prime of x is negative on the interval negative 2 to 2. Which means the original f of x was decreasing. Next, I check another point and I get that I am testing, let me test at x equals 100. So f prime of 100 is equal to 3 times 100 squared minus 12, which is certainly positive. So f prime of 100 is positive. And I can draw my conclusions about f prime of x on 2 to infinity. F prime is positive on this interval, so f of x is increasing. How to interpret this? Well, on negative infinity to 2, f of x is increasing, so this moves upwards. We actually hit our x equals negative 2 value, and then the function is decreasing. So the function moves downwards until we get to x equals 2, and then it is increasing again until positive infinity. Looking at these points, what I can tell is that f of x has a local max at x equals negative 2, and f of x has a local min at x equals positive 2, because I was able to interpret the shape of the graph from the sign chart. Now what I actually need if I want to figure out the value is I need to plug in this x value into the original. So if I calculate that out, what I get is 16 for x equals negative 2 and negative 16 for x equals 2. So the local maximum of a function is the y value, and it occurs at the x value. For instance, on this function, the local maximum is negative 2 comma 16. The way I would phrase that is, f of x has a local maximum of 16 at x equals negative 2. So